Dolphin is no longer the storm it was a week ago, but that does not make the situation around Okinawa harmless. The cyclone that exploded into a super typhoon over the western Pacific has weakened, sharply expanded, and moved into a far more consequential position. By Friday afternoon in Japan, the Japan Meteorological Agency placed Typhoon Dolphin just north of Okinawa's main island, with maximum winds around 144 kilometers per hour. That is far below Dolphin's peak intensity, yet strong enough to disrupt transportation, damage exposed structures, generate dangerous seas, and drive heavy rain across islands that are now directly under its circulation. That is the first correction this story needs. Dolphin is not strengthening now. The strengthening phase happened earlier, when the cyclone was still far out over the Pacific. What matters today is what happened after that burst of intensification. The storm broadened, weakened from its peak, and carried a much larger area of strong winds toward populated islands. This is why judging a tropical cyclone only by its highest category can be misleading. Compact super typhoon over open water can be spectacular on satellite imagery, but a weaker storm crossing populated islands can create more immediate disruption. The question is no longer how powerful Dolphin can become, passes. The question is how much weather its current circulation can deliver while it passes Okinawa and then heads farther west. The rapid rise began in late July. National Weather Service advisories from Guam tracked Dolphin when it was still a tropical storm north of the Marshall Islands. On July 28th, one advisory listed winds near 70 miles per hour and described the system as rapidly intensifying. Within hours, it was upgraded to a typhoon by July 31st. Joint Typhoon Warning Center information identified Dolphin as a super typhoon with 1-minute sustained winds around 135 knots. The transformation from an ordinary tropical storm to an extreme cyclone happened over a remarkably short span of time. The satellite presentation explained why forecasters were so focused on it. Dolphin developed a compact, well-defined inner core and a small eye surrounded by very cold cloud tops. In that configuration, thunderstorms were not simply scattered around a broad low, they were rotating around a tight center, releasing latent heat, lowering pressure, and reinforcing the circulation. The result was the kind of feedback loop that can drive rapid intensification when ocean and atmospheric conditions align. But tropical cyclones do not remain frozen at peak structure. Their own strength can trigger internal changes. As an intense eye wall contracts, a second ring of thunderstorms may form outside it. That outer ring can begin competing for moisture and angular momentum. The original eye wall weakens while the new one gradually takes over. The process can temporarily lower peak winds even as the wind field expands. Dolphin went through structural changes of this kind as it moved west-northwest, and its peak intensity did not last. That transition is central to what people in Okinawa are experiencing now. The loss of super typhoon intensity does not mean the atmosphere suddenly switches off. A broad typhoon still contains enormous rotating mass, deep tropical moisture, and powerful pressure gradients. Strong winds can extend far from the center. Rain bands can train across the same area. Waves generated over hundreds of kilometers of ocean can continue arriving even after the strongest inner core winds have weakened. On Friday, those hazards were no longer theoretical. Reuters reported that authorities had issued evacuation orders affecting nearly 260,000 residents in Kagoshima and Okinawa prefectures. More than 500 flights were canceled. Toyota suspended work at 9 factories. Associated Press reporting said Naha Airport closed, and all domestic and international flights there were canceled, while hundreds of people had taken shelter in evacuation centers across Okinawa. These are not impacts from a hypothetical future track. They are consequences occurring while Dolphin is already passing the region. The danger is also layered. JMA warned about violent winds, heavy rain, and high waves. Posts also raised the possibility that a linear rain band could develop, concentrating intense precipitation in a narrow corridor and increasing flood risk. That means a resident can be outside the strongest part of the eye wall and still face serious conditions from rain, gusts, waves, or localized flooding. And the timing matters because the storm is moving through a region that has other vulnerabilities. Parts of southern Japan are already dealing with the aftermath of a recent destructive earthquake. Reuters reported that thousands of people in Kumamoto remained in evacuation centers as Dolphin circulation spread strong winds across Kyushu. AP described residents covering damaged roofs and walls with blue tarps to limit additional water intrusion. A typhoon does not need to reach its historical peak intensity to compound damage that already exists. That is the deeper story behind the breaking update. Dolphin's most dramatic intensification is behind it. Its most important impacts may not be. To understand why, we have to separate 3 different things that tropical weather coverage often blends together: peak intensity, current intensity, and total hazard footprint. They can move in different directions at the same time. Dolphin is weaker than it was at sea, but closer to people. Its core winds have dropped, but its circulation has become broader. Its category has fallen, but its rain and wave hazards remain capable of causing significant disruption. That is why the word former matters in the final title, preserves what Dolphin actually became without pretending the storm is still a super typhoon today. And that is why the phrase hitting Okinawa matters even more. The current story is not about another round of strengthening. It is about the transfer of a once extreme ocean storm into a populated island environment where the consequences are now being measured in canceled flights, evacuation orders, dangerous seas, and hours of severe weather. One more point helps keep the current update in perspective. The peak wind number is only one sample from a huge circulation. Weather stations, satellites, radar, aircraft were available, and surface observations all contribute different pieces of the picture. A cyclone crossing an island chain can expose one location to its northern side and another to its southern rain bands, so conditions can vary sharply over short distances. That spatial variability is why one dramatic image should never be treated as a complete map of the storm. The reason Dolphin intensified so fast earlier in its life can be traced to a familiar tropical cyclone equation: heat, moisture, low enough wind shear, and a circulation organized enough to use them efficiently. None of those ingredients works alone. Warm ocean water provides energy, but a storm cannot convert that energy into extreme winds unless thunderstorms stay connected to the circulation and the vertical structure remains aligned. A tropical cyclone is essentially a rotating heat engine. Warm ocean water evaporates into the lower atmosphere. Moist air spirals inward and rises through deep thunderstorms. Water vapor condenses. Heat is released high in the storm. That warming lowers pressure through the column and strengthens the pressure gradient near the surface. Air accelerates inward. The rotation tightens, and more moisture is carried toward the core. When the upper level flow allows air to escape efficiently from the top of the storm, the cycle can intensify quickly. Dolphin entered a period when that engine became extremely efficient. The inner core tightened, the eye cleared, and the strongest convection wrapped around a small radius. Compact storms can change intensity rapidly because a relatively small part of the circulation contains a large share of the strongest winds. If that inner core becomes better organized, the maximum wind can increase very quickly. If it is disrupted, the maximum wind can also fall quickly. This helps explain why the phrase strengthening can expire in a matter of hours. A headline that was accurate during Dolphin's explosive growth would be wrong several days later, even if the storm remains dangerous. Tropical cyclone intensity is a moving measurement, not a permanent label. The other key ingredient is vertical wind shear. Shear describes how wind speed or direction changes with height. Well-organized typhoon wants the lower level center and the upper level circulation stacked vertically. Strong shear tilts that structure and pushes the most intense thunderstorms away from the center. Weak shear allows deep convection to remain wrapped around the core. During Dolphin's strongest phase, the environment allowed the storm to maintain a highly organized inner core. Later, as the storm moved into a different atmospheric regime and underwent internal structural changes, its maximum winds came down. That does not mean all storm energy disappeared. When a very intense tropical cyclone weakens, its wind field can spread outward. The radius of damaging winds can become more important than the peak value near the center. For islands and coastal regions, this changes the experience of the storm. Instead of a tiny zone of catastrophic wind surrounded by much weaker conditions, a larger area can spend more time inside strong winds and persistent rain bands. This is why Okinawa can face a serious typhoon even after the super typhoon phase ends by Friday. JMA data cited by Reuters and AP placed Dolphin around 144 kilometers per hour in maximum sustained winds. That corresponds to a strong typhoon, not the monster seen in peak satellite imagery. But the circulation was close enough to Okinawa that Naha Airport closed, and flights were canceled. Strong winds, heavy rain, and high waves were expected to continue through the weekend. Those impacts are driven by the storm that exists now, not by the historical peak number. There is also an important difference between 1-minute and 10-minute wind standards. The Joint Typhoon Warning Center commonly reports 1-minute sustained winds, while the Japan Meteorological Agency uses a 10-minute sustained wind standard for its regional classifications. Those values are not directly interchangeable. Storm can therefore be described with different wind numbers by different agencies, without either agency necessarily being wrong. For a public-facing story, the safest approach is to identify the agency, preserve the averaging method when it matters, and avoid mixing categories as if they were one universal scale. The phrase super typhoon itself is another source of confusion. It is commonly associated with the JTWC threshold for extremely high 1-minute sustained winds. JMA uses its own classification terminology, craft. So when Dolphin is described as a former super typhoon, that refers to the intensity it reached under JTWC-style classification during its peak phase, not to its current JMA status near Okinawa. This distinction may sound technical, but it protects the central truth of the story. Dolphin really did reach extraordinary intensity. It really did weaken, and the region is really being affected by the weaker version. The current wind field also interacts with the storm's forward motion. Slow-moving typhoon can prolong exposure to rain and waves. Even when the maximum wind falls, a long duration of adverse weather can matter for drainage systems, transportation, power infrastructure, and coastal operations. Plains, the storm does not need to be at peak intensity every minute to create cumulative stress. Rain is especially sensitive to structure rather than category. Tropical cyclones contain deep moisture that can be organized into spiral bands far from the eye. Terrain can force moist air upward and locally increase rainfall. Bands can repeatedly cross the same location. JMA's concern about a possible linear rain band is important because it points to a hazard that cannot be summarized by the storm's maximum wind alone. High waves have a similar lag. The ocean remembers strong winds. Power, when Dolphin was stronger, can travel away from the core and reach coastlines well before or after the center's closest approach. Local winds then add short-period waves on top of that background swell. The combination can make coastal conditions hazardous, even where rain totals are modest. The mechanism behind Dolphin, therefore, leads to a counterintuitive conclusion. Coming can reduce the most extreme wind near the center while leaving a broad and dangerous hazard envelope intact. That is the specific exception that matters here. If you look only at the category, the story seems to be winding down. If you look at where the storm is, how broad it has become, what hazards remain, and how many people are under evacuation orders, the story is still very active. And that brings us to the next question. Where does Dolphin go from Okinawa, and what can we say about the next stage without turning a forecast into certainty? The short answer is that Dolphin is expected to keep weakening as it moves westward toward the East China Sea, and eventually the coast of eastern China. But the details still matter, because a weakening forecast does not mean every hazard declines at the same rate or at the same location. Associated Press reported that the storm was forecast to weaken over the weekend as it headed toward China's eastern coast, with landfall expected Monday morning. Plains. That is a forecast, not an observed event. The exact track, timing, and intensity remain subject to change as steering currents evolve and the storm interacts with land, cooler water, dry air, and changing upper level winds. Air. The large-scale steering flow is dominated by pressure patterns around the subtropical ridge. Tropical cyclones embedded on the southern side of that ridge are often pushed generally westward or west-northwestward. In the ridge's strength or shape can alter the track. A weakness in the ridge can allow a storm to gain latitude. A stronger ridge can keep it moving farther west. These are not tiny details when islands and coastal cities are separated by relatively narrow corridors. Dolphin, the track has already been one of the story's biggest changes. Early in its life, there was substantial attention on whether the storm might recurve more sharply. Instead, the system maintained a more westward component and eventually moved into the Okinawa region. That shift turned a remote ocean intensity story into a real impact story. The next stage will be shaped by the same principle. Location can matter more than category. A typhoon that weakens from very high intensity before landfall can still bring damaging winds and significant rain. A broad circulation can push water toward vulnerable coastlines. Rain bands can extend far from the center. The strongest winds may be over water while the heaviest rain falls elsewhere. And if the storm slows or interacts with other weather boundaries, rainfall distribution can become more complicated. That is why official local warnings should always outrank generalized category language. Plain resident does not need to know whether a storm once reached super typhoon strength to decide whether a current evacuation order matters. The relevant information is the warning that applies to the location now, wind, rain, flood, wave, or evacuation guidance issued by the responsible authority. Okinawa demonstrates that principle clearly. Reuters reported evacuation orders affecting nearly 260,000 people across Kagoshima and Okinawa prefectures. The order is not a declaration that every one of those people will experience the same conditions. Evacuation zones are designed around exposure, vulnerability, and local hazard thresholds. The size of the number shows how widely authorities are taking the threat seriously, but it should not be converted into a casualty prediction or a claim that the entire region will suffer severe damage. Likewise, the cancellation of more than 500 flights is a disruption metric, not a measure of storm intensity. Airlines and airports cancel service based on expected wind, safety margins, aircraft positioning, runway conditions, and operational constraints. Naha Airport's closure illustrates how a storm can produce major consequences even without retaining its maximum historical category. The same caution applies to the 3 minor injuries reported by AP. Those are real observed impacts as of the report, but they should not be used to imply a final casualty total while the event is ongoing. Tropical cyclone impact numbers often change as conditions evolve and damage assessments arrive. Pops. This is exactly why the script avoids building suspense around a casualty count. Instead, the useful question is what forecasters are watching. They are watching the location of the center relative to Okinawa and the Ryukyu chain. They are watching the storm's forward speed, power. They are watching whether the wind field contracts or remains broad. They are watching where the strongest rain bands set up. They are watching wave conditions and coastal exposure. And they are watching the downstream track toward China, where the forecast can still shift before landfall. Products. The public should also understand the difference between a forecast cone and a hazard area. A cone represents probable center positions based on historical track errors. It does not show the full size of the storm. Wind and rain can extend far outside the cone, and impacts can occur well away from the center line. Per France, for a large typhoon, focusing only on a thin forecast track can create a false sense of safety. Dolphin's current story is a good example because the circulation is larger than the pinpoint center. Area location can receive strong winds without the center passing directly overhead. Coastal waves can arrive from a distant part of the wind field. Rain bands can pivot across islands as the center moves away. The hazard map is therefore wider than the track line. There is one more complication around Kyushu. Crothers and AP both noted that communities in Kumamoto were still dealing with damage from a recent major earthquake. Some residents remained in evacuation centers, and damaged roofs and walls were being covered. This creates a compound vulnerability, but it does not mean the earthquake and typhoon are physically connected. They are separate hazards overlapping in time. The responsible framing is operational. Weakened structures and displaced residents can be more vulnerable when strong wind and heavy rain arrive. That distinction matters because disaster coverage can easily imply a dramatic causal chain where none exists. Dolphin did not trigger the earthquake. The earthquake did not create Dolphin. What exists is a difficult human overlap between two independent events. The forecast toward China deserves the same discipline. P's report says the storm is expected to make landfall on the eastern coast Monday morning after weakening. That is the current forecast window, not a guarantee of one precise location or impact level. Any production version of this video published later should recheck the latest track before using that line. This is why the current status deadline in the production package is intentionally short. Tropical cyclones can travel hundreds of kilometers and change intensity substantially within a day. A title that is accurate on Friday morning can become stale by Friday night. Promises. For now, the strongest defensible statement is that Dolphin is moving through and around Okinawa as a typhoon, no longer a super typhoon, while strong winds, heavy rain, high waves, and travel disruption continue. The storm is forecast to weaken farther as it heads west, but the threat does not disappear at the same instant the wind number drops. The final part of the story is therefore not about whether Dolphin can regain its old peak. It is about what a weakening tropical cyclone could still do before it finally loses organization over land and less favorable water. The storm's final chapter is often less photogenic than its peak, but it can be more important for the people underneath it. The eye may become ragged, the cloud tops may warm, the maximum wind may decrease, yet roads can still flood, ferries can remain suspended, airports can stay closed, power can fail locally, and waves can keep coastlines dangerous. That is the stage Dolphin has entered. The first practical rule is to follow the warning that applies to your exact location, not the category the storm had days earlier. Japan's warning system distinguishes among hazards such as heavy rain, landslides, storm surge, strong wind, and high waves. Local authorities can also issue evacuation instructions based on conditions that national storm categories do not capture. When an evacuation order applies, the important question is not whether Dolphin is technically weaker than yesterday. The important question is whether the local hazard threshold has been reached. The second rule is to avoid treating temporary calm as the end. Tropical cyclones arrive in rotating bands, so conditions can improve briefly between rain bands and then deteriorate again. Air wind direction changes as the circulation passes, while coastal waves can remain dangerous even after rainfall eases. In a large system, some of the strongest outer band weather may arrive well before or after the center's nearest point. The third rule is to separate observed information from forecast information. As of the current verification, Dolphin has already affected Okinawa and southern Japanese islands. Airport closures and evacuations have already happened. Strong winds and high waves are observed or ongoing hazards. The forecast that Dolphin will weaken and continue toward eastern China is still a forecast. Monday landfall timing is not yet history. That separation prevents two opposite mistakes. One is exaggeration, presenting the future landfall as certain and filling in damage before it happens. The other is complacency, assuming that because the storm is weakening, the remaining forecast does not matter. Both errors ignore what tropical cyclone forecasting is designed to communicate. Dolphin's entire life cycle shows why precision matters. On July 27th, it was a tropical storm with winds around 40 to 50 miles per hour in National Weather Service Guam advisories. By July 28th, it was rapidly intensifying and then became a typhoon. By July 31st, JTWC information placed it at Super Typhoon intensity. Several days later, it was dramatically weaker, but much closer to Okinawa. On August 7th, JMA information cited by AP and Reuters put maximum winds around 144 kilometers per hour near the main island plain. Every one of those descriptions can be true because they refer to different times and, in some cases, different agency wind standards. This is why the original title cannot survive unchanged. Super Typhoon Dolphin is strengthening describes the earlier phase. It does not describe Friday's storm keeping. That wording after the cyclone weakened would convert old evidence into a false current claim. The corrected title keeps the part viewers care about most. Dolphin did become a super typhoon, and it is now producing real impacts. Place. Former Super Typhoon Dolphin is hitting Okinawa. That is what is happening now. There is also a broader scientific lesson in how the storm evolved. Rapid intensification receives enormous attention because it compresses change into a few hours. It is visually dramatic and operationally difficult. But rapid weakening and structural expansion can be just as important for understanding impacts. A storm does not have to preserve a tiny, violent eye wall to remain hazardous. It can trade some peak intensity for a wider wind field and a longer exposure window. For emergency planning, that distinction is critical. Infrastructure responds to more than a single maximum wind value. Airports respond to crosswinds, visibility, lightning, and operational safety, while coastal communities face waves and surge. Mountainous terrain reacts to rainfall, and damaged buildings can respond very differently from intact buildings under the same weather. Transportation networks can fail because multiple moderate stresses occur at once. Dolphin is moving through a region where those systems are already being tested. More than 500 flights were canceled, according to Reuters. Naha Airport closed, according to AP. Evacuation orders affected nearly 260,000 residents across Okinawa and Kagoshima prefectures. Several people had already reported minor injuries. These are concrete signals that the hazard phase is underway, even though the peak intensity phase is over. What happens next depends on the storm's track and rate of weakening. If the center continues west and loses strength as forecast, the highest wind threat around Japan should gradually diminish. Rain and wave hazards may persist longer in some places. Farther west, the risk focus shifts toward whatever part of China's coast lies near the eventual track. The exact details need fresh official updates, because a tropical cyclone forecast can change faster than a documentary production schedule. That is why the source ledger includes a mandatory recheck before publication. It is not administrative caution. It is part of the science. Current location, intensity, warnings, evacuation status, and landfall timing are all time-sensitive facts. One thing does not need qualification. Dolphin has already demonstrated the full range of what a Western Pacific cyclone can do. It began as a tropical storm, far from major population centers. It intensified with extraordinary speed. It reached super typhoon strength. It restructured and weakened. Then, instead of disappearing harmlessly over open water, it carried a broad typhoon circulation into the Okinawa region. The satellite image at peak intensity showed a tiny eye surrounded by a nearly perfect ring of deep convection. The image that matters now is different. It is an island chain under layers of cloud, airports shut down, residents moving into shelters, damaged roofs being covered before another round of rain, and a large storm continuing west even as its maximum wind falls. That contrast is the final reveal. The most dangerous moment in a cyclone's life is not always the moment when the wind number is highest. Sometimes it is the moment when the storm becomes weaker, larger, and closer. Dolphin is no longer strengthening. It is no longer a super typhoon. But for the people in its path, the storm is still very much alive.